Hello everyone. So the next topic which we will be discussing here is about the respiratory volumes and capacities. So in this we will be discussing about the lung capacities, and there will be an introduction of different terms. For example, there is a tidal volume, then inspiratory reserve volume, expiratory reserve volume. So the introduction of these terms will be in these particular slides will be seen. So let's start with the first topic of this, that is the introduction. So what is it about? So there are lung capacities of different animals very based on their activities. For example, the lung capacity of cheetah is much higher than the humans. So there are different lung capacities and there are different measurements which are being mentioned here. So that will be discussed here. Why the cheetahs they have a higher lung capacity than that of volume? This is because they require a large amount of oxygen for their muscles that help them to run fast. So cheetah is considered as one of the fastest animal on the earth. So because of this, they require a large amount of oxygen for their muscles that will help them to run very fast. So that is why they have a larger lung capacity as compared to the humans. So the lung capacity of the elephants is also higher due to its large body size, because the elephants they have a large body size, and because of which the lung capacity is also higher. So next, so a human lung can hold up to a maximum of 6 liters of air. So if we talk about the human lungs, it have a maximum capacity of 6 liters of air. So the volume of air that is involved in breathing process can be evaluated with the help of a spirometer. So the instrument which is used for the measurement is the spirometer. So it is an equipment. So what is it? It is an equipment which is used to determine the total volume of air that has been inhaled and exhaled by the lungs. It is also used in the testing of the pulmonary function. So this instrument or this equipment is also used for the testing of the pulmonary function. The air which is in the lungs is measured in terms of the lung volume and the lung capacity. The lung volume measures the amount of air for inhalation or the exhalation. So this is what the air in lungs is measured in terms of volume and the capacity. Now we have introduced the term lung volume here, that it measures the amount of the total air which is being breathed in and which is being breathed out. So this is the lung volume. And if we talk about the lung capacity, then it is how much air can be inhaled from the end of the maximum exhalation. So this is what the lung capacity is. Now tidal volume, or it can also be represented as TV. So the volume of air that is inspired or expired during the normal respiration. So there is a normal respiration process in which a human being will inhale the oxygen and exhale the carbon dioxide. So this is a normal respiration process. So here the tidal volume is about 500 ml. And a healthy man can inspire or expire approximately about 6,000 to 8,000 ml of air per minute. So this is the tidal volume of a healthy human being. Now the next is inspiratory reserve volume. So it can be also represented as IRV. So can also be represented as IRV. Now an inspiratory reserve volume is a supplementary volume, and approximately 2500 to 3100 ml of air which could be effectively inhaled after the inspiration of a standard tidal volume, that is TV. Now additional, we can inhale, for example in this particular case we can inhale more than 500 ml. An additional volume of air a person can inspire by a forceful inspiration, and it is about 3100 ml of air in an average adult male, and it is 1900 100 ml in an average adult female. So this is the female one, and this was about the male. Next is expiratory reserve volume. So it can be represented as ERV. Now it is the additional volume of air a person can expire by a forceful expiration, and it ranged from about 1000 ml to 1100 ml. So it refers to the additional capacity of air, which is about 1200 ml, and they could be forcefully exhaled out after the expiration of a standard tidal volume. So that is TD. So this is the expiratory reserve volume. Now there is a residual volume also. So this is the total volume of air around 1100 ml to 1200 ml residing in the lungs after the reserve volume is emitted or breathed out. So the volume of air remaining in the lungs even after a forceful expiration, this is known as a residual volume, or reserve volume. The next is about the total lung capacity. So we have discussed till now the respiratory volumes. Now there is a term which is called as the lung capacity. Now the total lung capacity. The total lung capacity applies to the total volume of the air filled in the lungs after a forceful inspiration. So the lung capacity of an estimated healthy man is about 6000 ml. So the total lung capacity can be depicted as tidal volume, expiratory reserve volume, inspiratory reserve volume, and residual volume. So it is the sum total of these volumes, the total lung capacity. So this is the formula for the total lung capacity. It will include all the volume that we have discussed till now. The next is about the vital capacity. So what is vital capacity? It is nothing but the total volume of air that can be expired after a maximum inhalation or maximum air that a person can breathe in after forced expiration. So that is known as the vital capacity. Now it is very important measure for a person's respiratory health. So it is measured to for a person's respiratory health. Now, a decreased vital capacity is an indication of the restrictive lung disease, where the lungs cannot expand completely. So that is also an indication that the lung may be having some problem, because the lungs, they are not expanding properly or completely. So that is the case if there is a decreased vital capacity. And in case of a normal vital capacity, there is a improper functioning of lungs, which indicates the obstructive lung disease, where the lungs are blocked in the airways. So that is about the case with the normal vital capacity, and the formula for vital capacity is being depicted here is tidal volume plus expiratory reserve volume and inspiration reserve volume. So this is the formula for the vital capacity. Now inspiratory capacity, so it is the total volume of air a person can inspire after normal expiration. So this includes the total it includes the tidal volume and inspiratory reserve volume, and it has been seen that it is around 3600 ml. So this is the inspiratory capacity. Now there is a functional residual capacity, which can be represented as FR and C. This can be represented as FRC. So the volume of air that will remain in the lung after a normal expiration. This includes the expiratory reserve volume and the residual volume. So this is the formula for this. So if we talk about the measure for this, then the functional residual capacity is the total volume of air that is residing within the lungs after an exhalation process, that is the breathing out process, and it is about 2400 ml. So this is the functional residual capacity, or FRC. So this is just a diagrammatic representation of the different lung capacities and volumes. So there is the maximum inspiratory level, there is a vital capacity, inspiratory reserve volume. We have discussed all of these. There is a tidal volume, then there is the expiratory reserve volume, there is a residual volume. So all of these has been represented here. So this was about the capacities, respiratory capacities and the volumes.